Logistic regressions is a machine learning algorithm used mostly for the binary classifications problem. Binary classification problem, just like true, false, yes, no, 0, 1, that kind of problem, which is known as logistic regression. So we have a data, diabetic data. So we have to predict the patient is diabetic or not. So we have the binary answers, yes or no. Okay, so we are started with the program. So first we have to import some important library, like import numpy as np, import pandas as pd, import cbon as sns, and from sklearn dot model underscore selection, we have to import train test split, train test split. Okay, uh, train test splitting underscore. Okay, now we have to import one more library, which is from matplot, from matplot matplot lib import pyp plot pyplot as plt. Okay, so this is the all library which is we have required in the logistic regressions. Okay, so there is some problem, we will learn it. Model, we have to learn model. Okay, this is the array. Now we have to import our data. Data is equals to pd dot read underscore csv, and this is our data name. And now we have to call our data. So this is our data actually. Okay, so total 768 rows and 9 columns. Okay, in our data. So we have to read or understand about our data. Okay, so just ask about data info. So this is data informations. So we have total 9 rows, 9 columns actually. 9 columns. First one is pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, body mass index, diabetes, add age, a last outcome. So out we have to predict outcome. So these all, these all our, these all our, these all our. Just like this pencil, and this all our x, which is our independent variable. Okay, and this is our target variable y. Just take the initial 5 data list. So this is our initial 5 data list, data head, and some values of insulin is 0, which is not possible for the predictions, so we have to correct it. And now we have to go call data tell, data dot tell. So again here is some value of in insulin is 0 again, and some value of skin thickness is also 0, which is not possible. So we have to correct data, and the process we are doing in the last. Okay, so first we have to understand how is our data told. Just like we have to call data dot outcome dot values underscore value underscore count. So this is a most important part. So we have a data is not labeled actually. We have the data of 768 total, but the data is not labeled actually, because here is a non diabetic patient is 500. Here you have clearly seen we have 500 is non-diabetic patient. So 500 is our non-diabetic, and we have only 264 is the diabetic patient. That means the data is not labeled. So we have to label the data also. Okay, so we use, and you can see this informations in the historical data form. This is the count plot, and we clearly see this is our predicted. This is our diabetic data. This is all diabetic, and this is the non-diabetic data. So column. So we have total pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetic, age, outcome. So we have total. This is the total columns we have, and our data is not labeled data, which is we are seeing in this bar. They column one. This up again. This is our column one, and this is our column two. This is our column three. This is our column four. This is our column five. This is our column six. This is our column seven. This is our column eight. This is our column nine. Why? Because we have a extra column which is started with 0 in our data. I will show you. Just watch our data. This one is 0. So 0 is this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this is a 0 actually. Index value is a 0. Okay. So we are started with we are here. So this is our total 9. So when for column in data, first column in data, if plot is less than or equals to 9, m plot subplot, this is subplot. So we have total 9. We divided 9 into equal part, 2 factorial part. So 9 into 1, you can write 9 into 1 means total 9 folder make straight, which is very complex to use. Okay, which is very complex. 3, 3, 6, 7, 8, 1, 9, 8, 9. Okay, which is very complex. So we have tried to make a subfolder like subplot like 3 into 3. So this is right 3 into 3 plot, or and SNS histoplot x data column. X data column means column, who is the column? Column is the pregnancy. So first is pregnancy. After the pregnancy, we have to assign x label, x and y. X is column. A column is a pregnancy, and second is count. Okay. After that, plot plus one. That means the value is plot of is 2. Now the value plot is 2. So when the plot is 2, we have going here. 2 is a less than of equal to 9. Yes. So m plot subplot 3 into 3, second position. SNS histoplot x data column, and second column is glucose. That's why they are doing continuously and performing 3, 4, 5, 6, 7, 8, 9. Total 9 graphs they prepare for us. Okay. Now let's check it. We just run it. Okay. Now you are seeing we have total 9 plots. I will zoom out it. So this is our total 9 plot, and now we have to read carefully. So first one is pregnancy count, glucose count, blood pressure count, and skin thickness count, insulin count, BMI count, diabetic count, diabetic pedigree functions count, age count, and outcome count. So we have to study our data here. So pregnancy is not important for us because here we see clearly the data is going just like that. It's skewed data. It's skewed. Okay. Glucose value is something is our like normal distributions. So we can use as mean for the correctness for our data. Okay. Blood pressure is also a mean like data. Blood pressure is also a normal data. That means we can also use a mean, and we have skin thickness and BMI, insulin, and all the data we have to see clearly here. Now we're going to the age is not related to the relationship. So we have to relate all the graph with respect to outcome. So pregnancy and outcome we have to read by relation graph actually. Okay. So this is a graph which is histograph by data x pregnancies xuse.com. We have see the relation between this is the relation between pregnancy and outcome. So they all are non-diabetic, and the orange part is diabetic, and these overlap part is also diabetic. This is also diabetic. Okay, this is all diabetic also. So the area of diabetic is from here. We have diabetic area just here and here and here, from here until downward. Okay, so as a relation in this graph, we have okay when the pregnancy is here, here when the pregnancy is here, we see clearly when the pregnancy is here, but our diabetic patient, this is also a 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 diabetic patient. That means pregnancy is not affected our data actually. So pregnancy and outcome is not related to directly. Okay, so pregnancy is not related to data or outcome data, because here we have number of pregnancy is equals to number of diabetic. So we cannot predict like here is a zero pregnancy record, no pregnancy, but the chances of the diabetic is here very high. Okay, that means the pregnancy is not affected our outcome, our output variable. So now we have to open glucose versus outcome. So this is a label graph which is glucose versus this is a graph which is glucose versus outcome. So now we are check here if the glucose level is just 50, so no diabetic patient. 65, I think, 70, no diabetic. And if the glucose level is approx 80, the diabetic chances is yes, less diabetic chance. If the glucose value is higher than 75 to 80, 85, the chances of the diabetic is also high, and it is continuously increased. If the glucose value is increased, the diabetic chances of diabetic also increase. So that means glucose affected our data, outcome data. Okay, so it is our important relation. Okay, it is affect our information, uh, our outcome. So glucose is a very important variable for us, a very independent input variable for us for the predict the patient is diabetic or not. So glucose is very important. And now we have to check next, which is blood pressure. Now again we have to print the plot between the histoplot between blood pressure and outcome. You have just changed the values like BMI, insulin, skin thickness, and just analyze the data. Okay. So our first data like glucose is very important for us. Okay. Second is blood pressure. So the blood pressure here we have when the blood pressure is just reach blood pressure is 40 less than 40 or 40, there is no diabetic patient. When the blood pressure is increased, the diabetic level is also increased. Here. The value in the value of 70, the higher chances of diabetic patient. Okay, so they all are non-diabetic, but the overlapping part is a diabetic part. Okay, this orange part is also diabetic, and the overlapping part is also a diabetic patient. So we have to analyze that when the blood pressure is high, the chances of the diabetic is also high. That means blood pressure is also an important component for us. Okay, so we have actually two most important data till now. We have first data is glucose, and second is blood pressure. Okay, which is affect our outcome. So now we have to going next third relation, which is between our BMI and outcome. Okay, so this is the BMI curve actually, and we have seen again clearly when the value of BMI is very less, then no chances of diabetic, and the BMI value is higher, the chances of the BP is again high. That means it is also affect our data. It is important variable for us. So BMI is also important for the outcome. Okay, you see clearly, na? These all are increasing actually. When we are increase the value, the BMI, the chances of the diabetic patient is also increase. So chances also increase. So BMI is also important for predictions, diabetic or non-diabetic. So now we have to call next. We have to study one by one all the informations. Okay, because we inspect the informations, we collect all the information from the data, useful informations. We are going to insulin is nearby 100, the chance of the diabetic is also increased. But when the value of insulin is continuously increased from 50 to 210, 250, the value of insulin increasing, the chances of the diabetic patient is also increased. So insulin is also an important factor. If we are science background students, so we know that insulin is a hormone which is secreted from pancreas, and it is control our sugar diabetic level. So it is important for us when the insulin amount is higher and higher, the diabetic values also decrease. Okay, so here the insulin is less, the high chance of if insulin is less, high chance of diabetic. Okay, the 200 is affected area actually until 150, 75 to 210 is a very affected area for the insulin. So this is also important for the predictions of diabetic or non-diabetic patient. Now we have to study last relations, which is skin thickness and outcome. So here we see again a relation between skin thickness and outcome. If the skin thickness is high and high chances of diabetic, okay, somewhere actually it is just like going here and downward, and just one we have an outlier also. So yes, it is also depending. Skin thickness is also depending for the outcome predictions. So after the predict all relation, we have to go in check the data on the data. So we have zero in pregnancy, glucose will also have zero values, blood pressure will also have zero values, skin thickness is also zero. But we know that glucose is never be zero, blood pressure is not never be zero, skin thickness is never be zero. So we have to customize our data. Actually, this is the clustering of our data. So we have to collect all the 5 data, which is depending on our outcome. So now we have to call all the values in glucose, which is zero. Okay. First we have to call all the values. So this is the value where glucose is zero. Now we have to check the value where blood pressure is zero. We just call. So here is the blood pressure zero. As it is, you have seen clearly, here is the skin thickness is also zero, insulin is also zero, BMI is also zero. So we have to fill our data before we have to prepare our model. First we have to assign all the values in the data, because if the value is zero, that means the prediction is wrong. Okay, so we have filled the data, and the concept to fill the data is if the relation of the just like glucose have a normal distribution. So normal distribution, for the normal distribution we use mean, and exclude for exclude data we have to use median. Okay, so here glucose have a normal distribution, so we use as a mean, and blood pressure is also a normal data, we have used also a mean. But skin thickness, insulin, BMI, they all are skin thickness and insulin is our exclude data, that means median, and here we are using median, and BMI is also a normal data, so we are using mean. Okay, so the method for fill values in data.glucose.replace 0 where the value is 0, it is replace the value np numpy, we are calling numpy, and mean data glucose. Okay, so if the glucose value is 0, anywhere if the glucose value is 0, we have to assign the value as mean. So any value, like suppose we have mean of glucose is 23, so we accept 0 replace the 0, we have a new value assigned with 23. Okay, so this is the functions which we have called. In place 2 means this is the changes actually in original data. Okay, so we have to change all the zeros into a mean, median. Okay, now we assign the values for x. X values is all the rows, but from 1 to 6. 1 to 6. We'll just call here our data. You see clearly. See here your data. So this is your data. So we have to call in x variable in x for x this is our 0. So this is our 0. This is our 1. This is our 2. This is our 3. This is our 4. For assigning the values of rows, all the rows. So we started with 0 till end. Standard from 0 to, we have to start from 0 to last value. So we assign the value like from starting 0 to end 768. Okay, now we assign the column. We have to start 0 1 2 3 4 5 6 7 8. So we need only glucose, blood pressure, skin thickness, insulin, BMI. Not required for diabetic, not required for age actually. So we just call from here to here 5. So we started with 1 column, we end with n minus 1. Like if we require 5, we use 6. Okay, so this is our x input, x value. Okay, this is our x input. So now we check it. We have to assign values in x, all the values except outcome. Okay, so this is our method. Now we call y as outcome. Okay, so this is our data of outcome. Now we have to call train our model from sklearn model selections, which is also we have mentioned in library. When we are calling the libraries, we already assigned this information, so not required again and again. So this is the x train, x test, y train, y test, and x y test size 3.0. That means if we have 100 values of diabetic or non-diabetic patient, so 70% used for training data and 30% for testing data. Okay, testing data for 30%. Okay, so we assign the values testing and train and testing method. This is the train testing method, and from sklearn model import logistic. Now we train our model. Just call model is equals to logistic regression. Okay, and model dot fit x train on x test y train and y underscore train. So these are the information which is we are giving for the model. Okay, now we have to call it. Okay, so these are notifications. Our model is trained 70% from 70% data, train and test also. So now we call our predicted part y underscore predict is equals to, we assign a variable y predict is equals to model dot predict and assign a value x test here and just call it I is equals to, just check it, so some error, predict, spelling error, predict is correct now, yes it is correct. Now the time is test our data, so I is equals to model dot predict. Now assign the value continuously one by one. First we have to put value of glucose, and let me assign the values from this data. The value of glucose is 183, glucose value is 183, and next value for blood pressure, which is 64, value 64. Next is, okay, and the skin thickness is for this 23, so skin thickness is 23. Next is insulin. The amount of insulin for second is 30.5, 30.5, and the last value we have to assign, which is BMI, and the BMI for 183, 64, 23, 30, 23.5, 23.3 actually, 23.3. Okay, we have filled all the data from this row, and the output is 1. That means the person is diabetic. Now the time for check our model is doing correct or not information. We have to call I, and the answer is 1. That means our patient is diabetic. Okay, I hope you understand. If you have any kinds of doubt, please ask me in the comment box, and do like, share and subscribe. Thank you so much.